Day 208 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. You know how we do. We're doing LeetCode problems every day until we accomplish the goals that we're trying to achieve, whatever they may be. So if this is your first time at this channel, welcome, welcome. And if this is not your first time at this channel, welcome back. You already know we're still staying disciplined and staying consistent until we reach the end goal, y'all. So before we get started today, if any of y'all need some new Apple AirPods, go ahead and check out the link in the description and go get them from there. Then after you do that, bring a mouse right over here and click that subscribe button for me, y'all. And then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we could run up this engagement and we could push this content out to a broader audience, y'all. As Swift community members, it's up to us to help the community to grow, and one way we could do that is to push this content out with as many people as we could find that will watch it, y'all. So your support is appreciated when it comes to that. Now, with all that being said, y'all, let's get started. And today we have question number 289, Game of Life. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand because we want everybody to be able to learn something at the end of this video, y'all. And if you don't understand the solution at the end of this video, then you probably didn't learn anything, and that is not what we want, y'all. So let's get into it and see what the question says. Question says, according to Wikipedia's article, the game of life, also known simply as life, is a cellular automation devised by British mathematician John Horton Conway in 1970. The board is made up of an m times n grid of cells where each cell has initial state live represented by a 1 or dead represented by a 0. Each cell interacts with its 8 neighbors horizontal, vertical, diagonal using the following 4 rules taken from the above Wikipedia article. 1. Any live cell with fewer than 2 live neighbors dies as if caused by underpopulation. 2. Any live cell with 2 or 3 live neighbors lives on to the next generation. 3. Any live cell with more than 3 live neighbors dies as if by overpopulation. And 4. Any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. The next state of the board is determined by applying the above rules simultaneously to every cell in the current state of the m times n grid board. In this process, births and deaths occur simultaneously. Excuse me, y'all. Simultaneously. Given the current state of the board, update the board to reflect its next state. Note that you do not need to return anything. So, I know that seems like a lot, but it's not that difficult. It's only really 4 requirements we have to look for, right? So let's go through it. Let's look at example 1 so we can make it make sense. First, we have the board. The input, the board, is equal to a 2D array integers, right? We have the first array is 0, 1, 0. Second array is 0, 0, 1. Third array is 1, 1, 1. Fourth array is 0, 0, 0. And remember, each one of these arrays represents a different row. So this right here is the first row, right? 0, 1, 0. Boom. Then this right here is the second row, 0, 0, 1, right? Boom. Then this right here is the third row, 1, 1, 1. And this right here is the fourth row, 0, 0, 0, right? And then the output is another 2D array, 0, 0. The first array is 0, 0, 0. Second array is 1, 0, 1. Third array is 0, 1, 1. And the fourth array is 0, 1, 0. So let's see how they got this output from this input, y'all. So let's go back. Let's see if we could take a look at these requirements or these rules so we can see what's going on, right? So it says first, any live cell with fewer than 2 live neighbors dies as if caused by underpopulation. So if you look right here, first let's look at it at row 1, right? This right here. But this row right here, let's look at the picture. This one right here has fewer than 2 live neighbors, right? It only has 1. This is 1 live neighbor. This is the only live neighbor that it has. So that means this one is going to die. That's why the output is turned to a 0 over here, right? Because it died because it had fewer than 2 live neighbors. It only had 1 live neighbor, which was right here. So boom, we already know this row is going to be all zeros, because these zeros don't fit the requirement to become alive. If any dead cell with exactly 3 live neighbors becomes a live cell, but these zeros don't have 3 live neighbors, so they can stay dead or stay 0. This one does not have 2 or 3 live neighbors, or it has any cell with fewer than 2 live neighbors dies. So this one has fewer than 2 live neighbors. It only has 1, so that's why it died, and that's why it turned to a 0 over here. So let's move on to the second row. Boom. So the second row, we have 0, 0, 1, and then the output, you can see this 0 turns into a 1, and everything else stays the same. This 0 turns into a 1 because it has 3 live neighbors. Right here, rule 4 says any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction, right? So this 0 has 3 live neighbors. It has 1 right here, it has 1 right here, and it has 1 right here. This one, and this one are all neighbors to this 0, which means we could turn this 0 into a 1 like we did over here. Then we keep going. We have a 0 and 1. This 0 stays the same because it says any dead cell with exactly 3 live neighbors becomes a live cell as if reproduction. So you might be wondering, this 0 has 3 live neighbors. However, it says exactly 3 live neighbors. So this 0 has 1, 2, 3, 4, 5 live neighbors. So it doesn't fit that requirement with exactly 3. So it could stay dead as a 0. So that's why it's a 0 over here. And this 1 right here stays a 1 because it says any live cell with 2 or 3 live neighbors lives on to the next generation. So this one has 3 live neighbors, has a live neighbor right here, has a live neighbor right here, and has a live neighbor right here. So it could stay alive, and we keep the 1 over here. Boom. So let's move on to the third row, right? The third row is 1, 1, 1. As you can see, this one dies and turns into a 0. The other 2 ones stay the same. Let's figure out why. Well, we could see that this 1 only has 1 live neighbor, right? And we know from before, any live cell with fewer than 2 live neighbors dies as if caused by underpopulation. This 1 only has 1 live neighbor right here. All the other neighbors are dead, so that's fewer than 2. It needs at least 2 live neighbors to stay alive. It only has 1, so that's why it turns to a 0. This 1 right here has exactly 3 live neighbors. It has 1 right here, 1 right here, 1 right here, so it could stay the same. And let's see, it says any live cell with 2 or 3 live neighbors stays on for the next generation. Oh, excuse me, the exactly 3 only goes for the dead cells, not the live cells. Sorry about that. But this 1 live cell has 3 live neighbors, 1, 2, 1 right here, and 2 right here. It has 3, so it can live on. And this live cell has 2 live neighbors, which also fits the required number 2. Any live cell with 2 or 3 live neighbors lives on. This one has 2 live neighbors, 1 right here and 1 right here, so it can live on and keep going as well. So now let's look at the last row, the final row, see what happens. So this is a 0. For a 0 to come back to life, it's only one rule that says how a 0 comes back to life. It's the last rule, rule number 4. It says any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. This 0 only has 2 live neighbors, 1 right here and 1 right here, so it can stay a 0. This 0, however, has exactly 3 live neighbors. It has 1 right here, 1 right here, and 1 right here. So it could come back alive as if by reproduction, like it says in number 4. So that's why it came back alive, and it's a 1 over here. Then we're back at this 0. This 0 only has 2 live neighbors, 1 right here and 1 right here. That's not enough to come back alive, so it stays dead, and it's a 0 right here. And that is how we got this output right here. So let's look at example 2. It's a little easier. It's just 1 0 that comes back to life, and that is because all the 1s have 2 to 3 live neighbors. So they could, or all the ones have 2 live neighbors, so they could stay alive. This 0 has exactly 3 live neighbors, one right here, one right here, and one right here. So that is why it turns into a 1. So it's pretty much the same thing. It's just a shorter array makes it a little easier. But this 0 at the end comes back alive. And just so you know, the input board equals a 2D array. First array is 1 and 1. Second array is 1 and 0. Then the output is 2D array again. First array is 1 1, and it ends up being the second array ends up being 1 1 as well. So I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual code. Code's not that long. It's not that long. It's a little tedious, but not too bad. So let's get into it. First thing we're gonna do, we're gonna come inside this function, this game of life function. We're gonna declare another function, and we are gonna call that val. Open up the parentheses. We're gonna say underscore I. That's going to be an integer. Boom. Then we're going to say comma underscore j colon. That's going to be an integer as well. And it's going to return an integer. You guessed it, an integer. Boom. Open up the brackets. And we're going to say if I is less than 0 or I is greater than or equal to board.count or j is less than 0 or j is greater than or equal to board square bracket 0 dot count, then what we are going to do, we're going to open up the brackets. We are going to say return 0. Then we're going to come outside of that if statement, and we're just going to say return board square brackets I, come outside those brackets, square brackets j, come outside those brackets, mod 3 is greater than 0. If it's true, if that's true, we're going to say 1. If not, it's going to return a 0. Boom. Then after we do that, we're going to come outside of that function, and what we're going to do, we're going to declare another function. We're going to call this function neighbors. Neighbors like that. We're going to open up the parentheses. We're going to say underscore I colon. That's going to be an integer. Then we're going to say underscore j. That is also going to be an integer. And you already know, what do you think it's going to return? You guessed it, another integer. So then it's going to return an integer. We're going to open up the brackets. This is where it gets a little tedious, y'all, so stay with me, pay attention. Let's get into it. We're going to say val, open up the parentheses, I minus 1, comma, j plus 1. Boom, okay. Come outside those parentheses. We're going to say plus. Then we're going to say val, open up the parentheses, I, comma, j, minus 1. Come outside those parentheses, plus. We're going to say val, open up the parentheses. We're going to say I plus 1, comma, comma, j minus 1. Come outside of those parentheses, we're going to say plus. This time we're going to say val, open up the parentheses, I minus 1, comma j. Then we're going to come outside of those parentheses again. We're going to say val, open up the parentheses, I plus 1, comma j. Then we're going to come outside of those parentheses. We're going to say plus val, open up the parentheses, I minus 1, comma j plus 1. Then we're going to come outside of those parentheses again. We're going to say plus val, open up the parentheses, I, comma, j plus 1. come outside those parentheses, we're going to say plus val, open up the parentheses, I plus 1, comma, j plus 1. Boom. Now hold on. Let me make sure this is still okay. Yeah, make sure these parentheses goes with this val. I know it's a little long. Let's make sure it's not a space in there. Then after we do that, we're gonna come outside of that function. We're gonna say for I in 0 up to board dot count. Open up the parentheses. We're going to say another for loop for j in 0 up to board square bracket 0 dot count. That dot count should be outside of the array brackets. Dot count. Open up the brackets. We're gonna say let val equal neighbors. Open up the parentheses I comma j. Excuse me, y'all. Then we're gonna come underneath that. We're gonna say if, open up the parentheses, board square brackets I, come outside those. Oh, come on. No, that's right. Board square brackets I, come outside those square brackets, still inside the parentheses. Open up more square brackets. Say j. We're gonna say is equal. Excuse me, y'all. To equal sign 1. We're gonna come outside. We're gonna say and. 2 and signs, and open up the parentheses, val is less than 2, or val is greater than 3. Come outside those parentheses. Oh, hold on, my bad. Come outside those parentheses. Open up the brackets. Boom. We're gonna say board square brackets I, come outside those square brackets, square brackets j, come outside equals 2. Then we're going to come right here, we're going to say else if, open up the parentheses, board square brackets I, come outside those square brackets j, come outside those square brackets, equals 0, and this time we're going to say and 2 and signs, val equal signs 3. Open up the square brackets. We're going to say board square brackets I, come outside those brackets. Open up some more brackets. Square brackets j equals 3. Then we're going to come down here outside of that for loop, and we are going to say, come right here, we're going to say for I in 0 up to board dot count. Open up the brackets. Then we're going to do another one for j in 0 up to board square bracket 0. Come outside of that dot count. Open up the brackets. We're going to say board square brackets I, come outside the square brackets j, come outside those square brackets, mod equals 2. Now, that should be all she wrote, y'all. Let's run it. Told y'all it was a little tedious, but we got through it. Ooh, we got the wrong answer. So, let's figure out where we went wrong. I could assume, I think it's safe to assume it's somewhere up here. Like right here, this should be -1, not +1. Let's run it again, see if that's it. Let's see, and it's accepted, y'all, just like that, y'all. So let's see, let's submit it, make sure it stays accepted after we submit it, because we all know how LeetCode can get later. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. That's what I like to see. That's faster than a Bugatti riding past Andrew Tate and the rest of the brokies on the highway, y'all. So make sure y'all get one more look at the code. I know it's a lot. So get one more look at it. I hope you like it. I hope you learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.